Hello everyone, today in this video we'll be discussing the Unix super important questions, and this video is sufficient for you to score more than 80% marks. There are 28 questions in this video, one shot video for your Unix exam. So don't miss any of these questions. These are the most repeated and the super important questions from the previous schemes. All I've analyzed the previous papers and model question paper. And before starting, please do like and subscribe, and if you want the PDF of this, please DM me on the Instagram _AFUU, and please do like and subscribe to my channel. That helps me make more videos like this. So without wasting more time, let's get started. So the first question is explain Unix architecture. Okay, so here you have to make this diagram. Okay, this is a very simple diagram. You have to write here user, user, and user. Three users are there. So users will be accessing these functions. Okay, what users will be doing? Users will be accessing these functions. And at the first level, what you have dedications. Okay, like the application which you have is X Windows, spreadsheet, database, text processor, browser, and other compilers. All these are the applications which the user is using. Okay, that is at the top level, and little inside that level you will be having the functions which we run. Okay, and inside that we have the kernel which is interacting with the hardware. Okay, so this is the diagram you need to make for Unix architecture. So Unix architecture consists of three important agencies: the kernel and shell, file and the process, and system calls. Okay, so some information about kernels and shell. What is a kernel? Kernel is nothing but it is a system inside the memory which is very closely related to the hardware. Okay, it is very closely related to the hardware. It is the core of the operating system. Okay, so there are functions running inside it. Okay, it is loaded into the memory when the system is booted and communicates directly with the hardware. Okay, if you want to perform some operations with respect to hardware, we will be doing it through kernel. Okay, now what is shell? Shell is nothing but a command line. We'll be opening cmd, right, and we'll be giving command. That is called as a shell. Okay, it is just a ui between the kernel and the users. Okay, so computers do not have capability of translating commands into action, so it requires a command interpreter, which is also called as shell. Shell acts as an interface between the user and the kernel. Okay, this is the user and this is the kernel. In between, what we have is the shell. We'll be interacting with the shell. Shell will be interacting with the kernel. Okay, what is a file? File is an array of bytes. Okay, and the process is a name given to a file when it's executed. Okay, when a program executes. What is a system call? The inner calls. Okay, the internal calls which happen between the kernel and the shell is called as a system call. Okay, moving on to the second super important question, we have to explain seven salient features of Unix. There are seven salient features. Okay, the first one is it is a multi-user system. Imagine it like this: many people are using the system, so there will be multiple tasks. It is a multitasking system, and it is a building block approach. Means one by one, like a small building blocks, it will be arranged, and this is how it is organized. Okay, it is using the building blocks approach, the Unix. Okay, and there are toolkits present, Unix toolkits for different operations. It also supports pattern matching. Okay, we'll be discussing this in the upcoming modules. And programming facility is also present in the Unix shell. We can write our own programs and execute, and documentation is present with the help of man command. Okay, man means manual. If you run this command, the manual can be seen. We can learn from it how to operate the system. Moving on to the third super important question, we have with a neat diagram explain kernel and shell relationship. Okay, this is the diagram you need to make. This is the users who are interacting with the kernel. In between we have the shell, and shell consists of two things: utilities and application programs. So user is interacting with the kernel via this is the diagram you need to make, and kernel is interacting with the hardware. Okay, so these are some of the points of the kernel. The important key points are: it interacts with the machine's hardware directly. It interacts with the machine's hardware. Also, it is the core of operating system. Okay, and it's loaded into the memory when the system is booted. Okay, and the user programs are run on top of the system programs and the system calls. Okay, the program access is made via the kernel by system calls. Okay, and apart from providing support to the program, it also does important housekeeping, and some other points are also here. You can go through it. Okay, next is shell. Shell is nothing but a command interpreter between the user and the kernel. Okay, it is an interface between user and the kernel. Only one kernel is running on the system. There can be several shells running. Okay, one kernel is always there, but there are different shells for different programs. Okay, like that it is arranged. Okay, so this is an example: echo VTU Belgavi. So VTU Belgavi will be echoed here. How does this happen? Shell rebuilds the echo command by removing the multiple spaces. Okay, here multiple spaces are there that will be removed by the shell. Okay, so shell will do those kind of activities. Moving on to the fourth super important question, explain the internal and external commands with suitable example. The basic definition you need to keep in mind is when shell executes a command, from its own set of inbuilt commands. If there are inbuilt commands present that is not stored as separate files, it is called as internal command. It is an inbuilt command. Okay, this can be executed anytime rn and are independent. Suppose that we use an external file and execute some command, it is called as external command. Okay, the files will be stored in /bin. Okay, this is an example for internal command type echo. Okay, and ls is an external command because this we use another separate file. Okay, so that is the difference between internal and external command. Next we have write the syntax and explain the following commands. So few commands are there, the most repeated ones, so we have to remember the syntax and write an exam if the question comes. So first one is echo. The task is to display a message. Echo command is used in shell scripts to display a message on the terminal or to issue a prompt for taking user input. So example, echo enter your name. So the thing will come as enter your name here. Okay, whatever we echo here, that will be printed in the screen. Next is date. Date is to display the date. If you just type $date, the date will be visible. Cal is calendar. Okay, so cal, if you put, it will be the calendar will be shown. We can specify the month and year also, so that specific month or the year will be shown. Who are the users, who are the users in the system, that information. If you put who, the user's name and which date they have accessed latest, that will be shown here. Okay, and pass wd means changing a password. If you want to change the password, just give the command pass wd and then enter the current password it will ask, then the new password, re-enter the new password, then you click enter, then it will be saving your new password. Okay, and od means displaying in or data in octal. Okay, if you want to display some data in octal, we will be using the od command. So here we will be writing more o file. That means since we have written o file, it will be displaying the answer in octal format. Okay, next is the man command. What does man command do? It is used to display the manual for other commands, system calls, library functions and configuration files. Okay, and related utilities. So it provides the documentation for all of this. So if you type man ls, the information related to the command ls will be shown. Okay, printf is also same as echo. It is an alternative to echo. Okay, it is available on most modern Unix systems. So whatever we put inside the double quotes in printf, that will be printed. pwd is nothing but print working directory. Okay, don't confuse it with pass wd. Okay, pwd is print current working directory. Okay, so if we do pwd, where we are currently present, where we are running the command from in the terminal, that path will be printed here. Okay, that's all for the module 1. Moving on to module 2, we have give significance of lsl command with its options. Okay, very important question, don't miss this one. ls command with options. L means listing the file attributes. Okay, ls is used to obtain a list of file names. Okay, if we have 7 or 8 files present inside a directory, if you put ls, the name of those files will be displayed on the screen. Okay, for that ls command is used. Okay, we can also combine this option with other options, and the 7 attributes of the file are file type and permissions, then followed by link, ownership, the group ownership, who are the people present inside that group can access it, what is the size of the file, the last modification date and time, as well as the file name. So if we put like this ls and -l, at that time we'll be able to see all these information whichever I have discussed above. All those informations are present here. Okay, so this is what about the lsl command, significance of lsl command and different options which are being used here. Next is explain changing file permission in a relative and absolute manner. So changing file permission means what? Who is able to access or make changes, that will be changing. So in this case we have two types of changes, which is relative and absolute. Relative means the current changes are present, what you need to add or remove, that only will specify. In absolute manner, you will always specify what all the state should be there after the command is run. All the states we should specify. In the relative one, only the change which we want, that will be specifying. That's the difference. Okay, so the examples are given here. So in relative permissions, what we will do is we will be using the category, which is user, group or others, which you want to make change, or all also. Okay, whether you want to change the permission of a user or a group or others or all of them, you want to change the permission. And the operations will be assign or remove. If you want to give the permission, remove the permission. And permissions are r means read, w means write, and x means execute. So in this case, the first three are the users and second three are the group, and the last three are nothing but others. Okay, the others value is given here. Okay, so others who can access, read, write or execute, those values are given here. Okay, and the permissions. So based on that, and this is the owner name and the group ownership name and the time which is accessed, and this is nothing but at the end we'll be having the file name. Okay, which file we are going to make that change. So if you put chmod means change the permissions, u plus x, u means user. User should be added with the execute command permission. So it is just w here. When we added the execute command, x also comes here. So user will be able to read, write as well as execute after this command. Okay, that is the relative file permission change. Okay, the next type is the absolute file permission change. Here the octal numbers are present. Okay, read permission means 4, means 100. Write permission means 2, and execute permission is 1. Now for the user, group and others, we have to give the permissions if they are able to read, write and execute, or all of them. So basically we will be having the octal numbers here. 0 means no permissions. 1 means it will be 001, right? So at the last, execute will become true. If it is 2 means write only will become true. 3 means write and execute. 4 means read only. So based on this, all the combinations are covered. Whichever the answer is, that octal number will be assigning to it. Okay, so that is the absolute permission. Suppose that the you want to give the access for read, write. Okay, in that case what we will do is, initially what the thing is present, for all we have to add read and write. Okay, initially permission that will not be touched, read, write will be added. But here if we want to do it by absolute permission, we will be specifying the number is 6. 6 means read, write, and read, write has to be given to all means for the user, and second 6 is for the group, and third 6 is for the others. So for all of them the read, write is given. This is the absolute permission. For this we have to specify all the permissions. Okay, here only the relative permission is needed. Okay, that was about the changing file permissions. Moving on to the eighth super important question, we have explained 3 standard file supported in Unix. So for this, the standard files are input, output, and error. Okay, 3 are there: input, output, and error. Input stream represents the input connected to keyboard. Output is connected to display, and stream is the error messages that emanate from the command or the shell connected to the display, which is keep on coming. Okay, the errors, whenever it comes, this input will be used. Okay, this standard file. Now, standard input. Standard input can represent 3 input sources. It can be either keyboard, or it can be either a redirection symbol and another program which is using a pipeline that also can pass the data. Okay. How does redirection work? Okay, redirection will be using this symbol. Whatever the data is presented, that will be read. Okay, that is the reading operation. Now, output operation. Whatever we have to output it. So the file redirection symbols are used here, and the inputs another program using a pipeline, and the terminal default is the destination. Okay, on seeing this, the shell opens the disk file. The first thing, the disk file needs to be opened, or new file, wherever the writing has to be happened, and then the data will be transferred from it, and after that the data will be closed. Okay, so after the output, okay, the file will be closed. If there is any error, it will be shown in the screen. Okay, the errors. So there are different standards are there in that. There are 3 slots. 0 means standard input, 1 means standard output, and 2 means standard error. These descriptors are implicitly prefixed to the redirection symbols. Wherever the redirection is need to be done, previous to that, these symbols are pushed. Okay. Moving on to the next super important question, we have defined wildcards and explain the various shell wildcards with suitable example. What is a wildcard? A pattern is framed using ordinary characters and a meta character like star, which is using well-defined tools. If you want to do pattern matching, okay, we'll be using wildcards to fetch some pattern data. Okay, the pattern can then be used as an argument to the command, and the shell will fetch the particular data. Okay, so the following list explains the different types of wildcards. We have star here, question mark, ijk in the bracket, x to z in the bracket, not of ijk in the bracket, not of x to z in the bracket, and pattern 1, pattern 2 if it is matching or not. Okay, so the examples are given here. If you want to do it with star, okay, if you want to make the changes with star, so what you will be searching is ls star.txt. Star, it will include all of it. Okay, star, it will include all of it, any number of characters including none. Second is question mark. It matches a single character. If you put file question mark dot text, if any other letter is present inside instead of this question mark, what are the possibilities? For example, if file 1 text exists, it will search. If file 2 exists, if file 2 text exists, it will search. If file 1 2 exists, if we search, it will not take, because only one single character is to be matched, and 12 means 2 characters will be matched. ijk means either I, j, or k. Okay, whenever we search for this one, it will search either I, j, or k. Okay, and x to z means the range from x to z. If any things are there, that also please execute, means the output is shown like that. It means. Okay, next is not of ijk, means except ijk, other letters if it is there, that will be accepted. Okay, and the matches whatever the file names are there, that will be shown in the screen. Okay, So not of x to z means no letter between x to z including x and z. Okay, so that will be taken into consideration. And pattern 1, pattern 2, it matches the pattern 1, pattern 2, and so on. If you want to search the pattern 1, pattern 2, that will be searched here. Okay. Moving on to the next super important question, which is explain grep command and with its all its options. Okay, so what is a grep? Searching for a pattern. It scans for the input. Okay, where the input is there, it scans for it and it searches in the files. Okay, wherever it must be present. So command uses the following syntax: grep options pattern file names. Okay, so here grep is the command and sales is the pattern which you need to search and in which file emp.lst. So these are the answers which you get, and if they ask in the exam to explain the uh, this one, if they ask you to explain the grep command, you will have to write the same thing here. Okay, next is the grep options. They have also asked the options, right? If you put I means the in the pattern matching the cases are ignored. V means it doesn't display the lines. N means it displays the numbers along the line. C means it displays the count of numbers. L means it displays the list of file names. EXP means it matches multiple patterns. F means takes the patterns from the file. Capital E and F is treated as an ERE and matches multiple fixed strings. Okay, this is the GRP option which you can use. So one example for ignoring case. Okay, if you want to search Agarwal but without the hesitation of the cases, what we can do is -I. What it will do, it will ignore the caps here and it will just output the places where Agarwal is used. Okay, without the cases. Next, explain if, while, for, and case in a shell. Okay, so in shell scripting, the control statements. What is if, while, and for, and case? These are the control statements. Okay, so it controls the execution of commands based on conditions or iteratively. Here is the explanation for each of them. So if statement. If a statement is to execute a block conditionally based on whether a condition evaluates to true. There will be a condition. If that becomes true, we will be evaluating. Means we will be executing that command, whichever became true. Okay. So this is the example. If num is greater than 5, then do this one. If num is equal to 5, do this one. Num, if both are not there, num is less than 5, and we have to close the if condition by using fi. Okay, so num is 10 here, which is given to us. So number is less than 5 will be outputting. Okay. Next is while loop. In while loop, it repeatedly executes until one operation. It repeatedly executes until one operation. So the operation is count is less than or equal to 5. But what is the count? 10. Is 10 less than or equal to 5? No. So it will just stop here. Okay. Next is for loop. In for loop, what we do? For loop iterates over a list of range items. Okay. There are many items. It will iterate over it. Okay. And whatever the answers we get, that will be printing. Next is case statement. A case means it will compare each case and which is the most probable one it will be taken. So read P, enter a letter. A letter is entered and what we will be doing is we will be giving the chance. Is it this letter or is it this letter? Okay, based on the letter which is matched, that will be executed. So if I have entered A, it will be getting A. If I enter B, it will be getting B, and so on. Okay, so this is something else like the what is this one? This is the case statement. Okay. Moving on to the next super important question, we have described the logical operators for the conditional execution. Logical operators two are there for conditional execution: double, ampersand, and or. Okay, it provides two operators that allow for conditional execution: double, ampersand, and or. So here CMD and CMD2 means both the CMDs together. Or means either this one or this one. Okay, so consider a file emp.list, cat emp.list. So cat means it will output the list here. Okay, and grep director in emp list and echo pattern found in file. So here if the pattern is found in file, that means the this is safe wherever it is. Okay, so pattern is found in file means that value which is there, that will be existing. Okay, if it is not found means it is not existing, and for that only the grep is used, right, for finding if the pattern exists or not. Okay, that's all about the module 2. Moving on to the module 3, we have the first question: explain the following functions with the prototypes and examples: mkdir, rmdir, and fcntl. So mkdir, the first one, what is mkdir? It is a command in bash we use to create new directories. Mk means make and dir means directory, make directory. So mkdir and options are given here and directory name which you want to create. Okay, so common options are p, which means it creates the parent directories. V means it provides the verbose output. Okay, so an example is here: we create a directory and assign the permissions to it and create a verbose output. Okay, what is rmdir? Removing the directory. Okay, just have to write rmdir and the directory name and that will be removed. Okay, and next one is fcntl. Fcntl helps the user to query or set flags. Okay, what it does, it set flags. Okay, and closes on exec flag of any file descriptor. So fcntl is used for helping the user to query or set flags on the close on exec flag of any descriptor, file descriptor. Okay, so the arguments are here. The first argument is the file descriptor, which is present here in fdesk. Second argument is cmd, which is specified whatever the operation is to be performed. Third argument depends on the actual cmd value. What is the actual cmd value? Based on that, the third number is defined, and possible cmd values are defined in the third argument is dependent on the actual cmd value, and the possible cmd values are defined in the following header. Okay, next is discuss various Unix system implementation. Okay, this is about a theory part, so you just have to understand what it is and try to know as much as you can so that you can fill the answer sheets. Okay, so Unix system was released, right? After that, some implementations are there similar to it. Okay, so what are those implementation? The first one is Unix system V release 4, SVR4. So here the developer is AT&T, and the key features are the following: unified features, introducing the PROC in the file system, and provided good URL init. Okay, and cron. So the tools are also present which run at the user kernel level to help the user with ease. Okay, this is the Unix system V release 4. Second is 4.4 BSD. This is the light version of BSD. Okay, here the performance is focused with networking and portability as well, and enhanced TCP/IP stack. Okay, the stack which we are using, that is enhanced level, and NFS is used, network file system, and virtual memory is used. So provide enhancements like the CHSL and VI editor. Okay, so we use the both basics for modern BSD like FreeBSD and NetBSD, and major influences are working on modern operating systems. Okay, FreeBSD, it's also a project derived from the 4.4 BSD. Okay, it is used for known for stability, performance, and advanced networking features. Okay, so ZFS file system and jails lightweight virtualization, frequently used in servers and embedded systems. Okay, it is used in popularly in Hitling and critical server infrastructure. Widely regarded as one of the most reliable open source Unix system. The FreeBSD is the most recognized one. Next is Linux. Linux is nothing but the Unix-like, okay, but not Unix certified. Linus Torvalds open source community distribution has released this. Okay, the Linux operating system. Okay, so here it is fully open source. We can modify it according to our own requirement. And next is Mac OS. Apple also uses the Linux only. Okay, and next we have the Solaris. It is developed by Sun Microsystems, and the known features are known for the stability and built on SVR4 with many BSD features and optimized for enterprise workloads. Okay, for enterprise workloads we will be using Sun Microsystems. Okay, moving on to the next question, we have explained with the neat diagram how a C program is started. Okay, this is very easy one. You just have to remember these three things. So what is the first thing? User function. Second thing is main function, and third is C startup routine. So when an execution command comes from here and the routine is started, a call is made here, and the call is made to this level, and the call is not written, so it comes to this point here in the exit, and everything which we are working upon, it is in exit only, and the documents which are made ready. So everything comes under exit in this case. So how do we ensure that the other functions are also covered? Okay, so it is given here, from any of these places you can directly exit and come to the safe place, which is the exit function, which is written here now. Okay, this thing is connected with the kernel directly. So whatever the things which has happened here, there are different types of exits here. Those things are present in the information type here. Okay, so when a C program is executed, the following sequence occurs. First, kernel role, it loads the program into the memory. Okay, firstly a program is loaded into the memory using exec call. Then C startup routine is run. In that, global variables, input output, and command and arguments are prepared. Okay, and then the startup routine starts and the main function gets called. Okay, so when a main function is called, then the normal user function that is being executed. Okay, and program termination happens using exit. Okay, whenever we exit, the termination happens. There are 8 ways of terminating a program, which we'll be discussing now. Okay, so exit handlers are used for that. So key points in the diagram you have to mention: this one, user functions and main function. Okay, user defines the main logic for the program, and the user defined functions are called by main program. And the exit flow is: exit is called execution of exit handlers, startup IO clean, and return to the kernel. Okay, and the kernel role is given here. It is responsible for starting the program exec and reclaiming the resources upon termination. Okay, if a process has been used and the process terminated, the resources allocated to that process will be released. Okay, and that everything is handled by kernel role. Kernel. Okay, Next, moving on to the next super important question, we have get R limit and set R limit. Okay, R means resource, get resource and set resource limits for the process. Okay, so this limit helps resource control resource usage such as CPU, time, memory, file, etc. So get R limit. This is the syntax here. We have resource and R limit. R limit. Okay, the description is it retrieves the resource limits. Okay, and the parameters are given here. Okay, and the return values 0 on success and -1 on failure. Okay, and sets err no. Okay, and the structure of our limit is our limit current, our limit max. The current, what is the resource limit and what is the max resource limit we have. We need this information for keeping track if it is going to be over or not. Okay, and set our limit means we are setting the limit. So in what resource, how much limit you want to set. Okay, what resource, how much limit you want to set, that will be specified here, and it is same as get our limit, but we'll be setting it here. Okay, so it will be a reverse of it. So it returns 0 on success, -1 on failure, and sets err no. Okay, moving on to the next super important question, we have set jump and long jump function. Very important. Okay, the set jump and long jump functions in C are used to implement non-local jumps, enabling control to jump back to a specific point in the program, bypassing the normal function call and return mechanisms. Okay, so here we are just directly by reaching to the place where we want to reach by jumping, and here we are bypassing the normal function call. Okay, this is set jump and long jump. Okay, so this is the exam means the syntax present here in set jump, and the environment is taken here. Okay, set jump saves the current program state into an environment like the buffer of the type jmp buffer. Okay, it is typically called in a function where you want that jump back in case of error. If any error comes, you want to jump back to the place where you had stopped. Okay, for that places we'll be using set jump. It returns 0 when initially called and non-zero when it is control is transferred back to long jump. Okay, so it acts as a checkpoint. So this is the main thing, long jump. It does the main task here, and sub jump, set jump will just do a small part of it. Okay. So description. Here we are taking the environment where the changes need to be made, and values also taken here. Okay. So description. It restores the saved program state from env to setjmp. Okay, and it transfers back the control to the back to the point where setjmp was called. Okay, if you are using long jmp, wherever that jmp was defined, that place it will go. We are just setting using setjmp and jumping using longjmp. Okay, setting and doing it is different. So the parameters again the same thing here. Env is nothing but a buffer containing the saved programs from the state, and val is value returned by the setjump function. Okay, moving on to the next important question, we have 8 ways to terminate a process. Very important from the exam point of view. So there are 8 ways. 5 are normal and 3 are abnormal. Okay, so normal means return from the main. Okay, and calling exit or underscore exit, or return from the last thread, calling p thread underscore exit. Abnormal ways are abort the termination, and if you are receipt of a signal, you'll be staying there only. And next is the response of last thread to the cancellation request. For this, the termination of the process cannot happen. Okay, so here's the brief overview you need to write for each of these. Okay, so normal termination, return from the main. If you are returning from the main means all the process which are needed to be executed, that is over. Okay, that is returning from the main. Next is calling exit. Exit means stopping and performing the things which is actually required at that point of time. Okay, and calling exit or capital E exit, it is immediately terminate a process without performing the cleanup operations. If you want to do the cleanup operation, we'll be using exit. If no cleanup operation, it is underscore exit. Okay, and return of the last thread from the start routine. In multi-threading, when last thread is finishes its work, it returns from the last start routine. The process terminates. Okay, so process will be terminated if there is no last thread present. Okay, and pthread exits from the last thread, where a thread called pthread exit, it terminates. Okay, and it is the last thread in the entire process terminates. Abnormal termination, if an abort signal is taken or CKVRT, or a receipt of a signal like signal kill, signal term, proposes a process to terminate. Okay, so that's why it is called as abnormal. Okay, and the last one also is the same thing here. The last thread is the cancellation request. Okay, if a thread receives a cancellation request and terminates, the entire process may terminate, and if it is the last running thread. So we have to always check if it is the last running thread or not. Okay, that was about the module 3. Moving on to the module 4, we have explain fork and vfork system calls. How does fork differ from vfork? Now basically what is fork? Fork means duplicate, make a copy. Okay, fork means make a copy. Okay, fork is equal to copy. Now existing process can create a new job by calling the fork function. So whenever we call a fork, it will create a new function here. Okay, by the example you will understand what I am trying to say. So this is the syntax for the fork, and the new process which is created by the fork is called child process, and it is called once but returns twice. Okay, so only difference between the returns is that it returns a value if the child value in the child is 0, whereas return value in the parent process id of the new child. Okay, so we'll be getting two processes instead of one, so parallel execution can happen. Okay, so some more information is given here, can go through it, and the programs are given here. See, whenever we call fork, it gets doubled. Okay, whatever the task is performed, it will be performed by two things. Okay, so hello usp is printed by this first thing, because for another thing was created which is also having printf hello usp, so hello usp is printed twice. Now normally printf, that will print only one time. Fork, if you do and print, it will print two times, because one is printed by the parent, one is printed by the child. Now what is vfork? The function vfork also has the same calling sequence and the same return values, and it is intended to create new process. Okay, when the process of the new process to execute a program. So vfork, what it does, it creates a new process just like the fork, without copying the address space for the parent and the child. Okay, this was not present, as the child won't reference that address space. The child simply calls exec right after the fork. Okay, you can go with this answer itself. Instead, while the child is running it, until it calls exec or exit, child runs in the address space of the parent. This optimization provides efficiency gain. Okay, another difference between the two functions is that vfork guarantees that child runs first. Okay, or else if parent id runs first, it might be causing an issue. So this is the code which is present here, which explains the thing which I have just told you. The child executes first, then the parent executes. So you need not memorize it like this, just you have to write an answer which is similar to this one. Okay, they will not read it, you will be getting marks if you write something similar to this one. Okay, don't spend more time understanding this one there, because there are many functions out there. Just remember a few key points, like you have to write if condition here, error, else if, what we have to do, and plus plus, this is the increment operator, exit you write here. So like that you keep on doing. Okay, moving on to the next super important question, we have the write a short notes on the following exec and race condition. Now what is exec? Exec means execute. When a process calls one of the execute functions, it is completely replaced by a new program. Okay, if a new function comes, it is completely replaced. Okay, and the new program starts executing at its main function. So process id does not change across exec, because new process is not created. Exec namely replaces the current process. What is the current process there? That it will replace. Okay, that is a task of exec. So this is the different options available in exec: exec v, le, vep, and vp. So these things are present with the different parameters which are present here. Okay, so these are the 6 exec functions. So the first difference between these functions is that takes uh, the first four takes a path name argument, whereas last two take a file name argument. Okay, the first two takes path name, and second two takes the file name argument. Okay, so that is a difference in the parameters. The next difference is concerning the passing of arguments, how we are passing the arguments. L stands for list, V stands for vector. We are passing it as a list or a vector. Okay, and the function xl, xlp, xle require each of the command line to be new program as separate programs. Okay, for the other three functions we have built an array of pointers. Okay, so it's not required. The final difference is passing of the environment to the list. The entire environment is passed to the new program, so that the information will be very clear. The two functions whose names end in an e allow us to the last two. Okay, the two functions whose name ends in exle and exeve, it allows to pass a pointer to the an array of pointers with the environment strings. Okay, now what is race condition? Race condition means two processes executing, who should execute first, a fight is going on there. That is called as race condition. A race condition occurs when multiple processes are trying to do something with shared file data, and the final outcome depends on the order in which the process to run. In which order it is coming, that order only it will run. Okay, so no matter what is the status and priority of it, in what order it came, it will be running. That is the race solving the race condition. Okay, that is how an attempt is made to solve the race condition. So this is the program which is given here. Here also we are trying to output the child first, then the parent. So here the same thing happens, the child outputs first and the parent outputs it afterwards. Okay, so this is a condition of race condition, when both the things are present, and it depends on few factors. Based on that factors, first something gets outputted, next time something else gets outputted. Okay, it depends on the time as well. Okay, so To modify the program to avoid the race condition, we'll be using wait. Okay, we'll be adding here tell wait. Okay, and we'll be calling the function wait, and we are also using tell child wait child. Okay, these functions if we use, we'll be easily able to avoid the race condition. Okay, when we get this program, run this program, the output as we expect, there is no intermixing of output from the two processes. It will be a single one. Okay, next is water pipes. Okay, water pipes and what are its limitations? Okay, write a program to send data from a parent to child over a pipe. Now, first question: what is a pipe? It is the oldest form of Unix system, IPC. Pipes have two limitations. Okay, it has two limitations. What is an oldest form of Unix? Okay, historically they have been half duplex. Okay, pipe can only be used between processes that have common ancestor. So these are the two limitations that are present here. Okay, more than two are also there, which we'll be discussing. In case you forget this one, that you can use. So a pipe is created by a process that a process calls for, and the pipe between used between the parent and the child. Okay, so this is the syntax for the pipe here. You can go through it. Next is the file arguments are presented. File 0 is for open for reading, and file 1 is open for writing. Okay, so half duplex is given here. This is the half duplex with the user process only, and this is with the kernel as well. Okay, and pipe from parent to child. This is the parent, and it is pipe here, and it is reaching the child. Okay, that is the pipe from parent to child. Next is the limitations of pipe. It is unidirectional, data size limitation, no random access. It has some blocking behavior. It relates to the process, no error handling, message delimitation, limited flexibility. How much you can remember, right? You can expect. If you write more, you can expect more marks. Okay. So a C program to send the data from parent to child. The question they had asked, right? A C program to send the data from parent to child. So this is the C program. Here the pipe is defined here. So pipe FT. This is PID and message, and this is buffer. And if it is equal to -1, means it will be shown as not available. Okay, it is a unavailable pipe. Okay, in case if it is not there, we will be creating a child process, and after we create a child process, if it is 0, we will be closing the right end of the pipe. Child doesn't write, else we will be reading the data. Okay, child will be reading the data, and then close the read end of the pipe and close the read end of the parent as well. Okay, then write whatever the message is present and close the writing function as well. Okay, and here is the wait null function. Okay, so the explanation is also given here very briefly. Pipe is created, parent process writes a message, child process read the message, descriptors are closed appropriately, parent waits for the child to finish the wait function. Okay, moving on to the next one, which is what is FIFO, and explain with the neat diagram client server communication using FIFO. FIFO, it's nothing called, it is nothing but it is called as pipes. Okay, it is first in first out, but it is a separately different topic. The pipes, it is called. Okay, pipes can be used only between the related process when a common ancestor has created the page. If there is no common ancestor, it will not be much lasting much longer. Okay, so this is the MK FIFO, which is the make FIFO. Okay, so here some more information is given. You can go through it. There are two uses of FIFO. The first one is used by the shell command, and second one is it are used as rendezvous points. Okay, in the client server application, two things, two benefits are there. Okay, so in client server communication, how does FIFO help? Okay, it helps to send the data between the client and the server. Basically, the server and client wants to share data, and Unix does that operation. Okay, in the form of FIFO. Okay, and there's a well-known FIFO where the data gets sent, and there is a multiple specific. There can be specific FIFOs also, that also will be showing in the diagram. So it will just forward the data. Okay, it will verify and forward the data between the server and the client, and what information who can access, that also check is made. Okay, so this is the server, and this is the well-known FIFO. From the client side, we'll be sending the write request and operation, which will be gone to well-known FIFO, and that will be transferred to the to the server via read request. Okay, and if it is going through the client specific FIFOs, it is the write and read replies. Okay, so that was a client server communication using FIFO. Next is explain popen and pclose function. What is popen? Since a common operation is used to create a pipe in another process to read its output or send its output to the IO, library has historically provided the popen and pclose function. These functions are used to send or receive an input. Okay, so this is the syntax of it. Okay, and in pclose, this is the syntax for pclose or termination, process termination. Moving on to the next one, we have explained wait and wait PID function. What is wait? When a process terminates, either normally or abnormally, the kernel notifies the parent by sending the sick child signal to the parent. Because the termination of a child is termination of a child is an asynchronous event. It can happen at any time while the parent is running. This signal is asynchronous notification from the kernel to the parent. Okay, and it can ignore the signal. The parent child can the parent process can ignore the signal, and it can also block if all of its children are still running, and then it return immediately with termination status of a child. Okay, if a child is terminated, it is waiting for the termination status to be fetched, and immediately return immediately with error. Okay, if you don't have any child process. Okay, so here the syntax for the wait and wait PID is given. Okay, and the difference between the two functions are as follows. The wait function can block the color until the child process terminates. Until and unless the child process terminates, it is blocked. Okay, this is one thing in the wait function. Wait PID, it doesn't wait for the child to terminates. It has a number of options that to control which process it waits for. Okay, so it already has terminated and is a zombie. Okay, so wait returns immediately, and the child status otherwise the block the caller until the child terminates. Okay, so these are the different scenarios inside wait and wait PID. Okay, wait PID is for parents, wait parent ID. Okay, so both the function, the argument cell dialog is a point counter to an integer. Okay, if it's a not null pointer, termination status of the terminate process is stored and location pointed to by in the argument. Okay, moving on to the module 5, we have define signal, explain sigprocmask function with a diagram. Here some functions are present which are the most important ones, which I'll be discussing in the module 5. Don't miss any of them. Okay, learn them all. So the first thing you need to know is what is the definition of signal. It is a software interrupt. Okay, it is nothing but a software interrupt. That is a signal. Why we use software interrupts? It provides a way for handling asynchronous events. A user at a terminal is typing at the interrupt keys to stop program or start a next program. In that case, the signals are used. Okay, and what is a signal mask? Signal mask is it a child process inherits everything from the parent. Okay, so even the mask categorization, everything is inherited here. Okay, but any pending signals for the parent process are not passed on. Okay, that's why mask is used here. A process may query or set its signal mask via the sigprocmask API. So this is the syntax which is given about the signal mask, and the reason why we use signal mask also, that is also discussed. Okay, so this is the syntax you need to write for sigprocmask. Okay, here some other command arguments are there, and with their meanings you can go through it. Next is example program where sigprocmask is used. Okay, wherever sigprocmask is used, that is an example program here. So here it is checking sig integer signal. Okay, sig int signal is used here, and we are setting the values here, and in between we have the sigmask. Okay, initialize the set. Next is here get the current signal mask and set the sig init and the sig segv. So here we are setting some different flags, and here the mask is taken and done some comparison. Moving on to the next super important question. This is a very interesting question because in this question we'll be seeing about the Doraemon as well. Okay, this is the robot Doraemon. Okay, so the question is explain Doraemon characteristics and the coding rules. Okay, inside the Doraemon, what are the coding rules present and what is the Doraemon process? Explain coding rules and error logging. Okay, so few concepts are present here. Let's have a look. Also they can ask you a program to transfer the normal process into a Doraemon process. Okay, so who is Doraemon is nothing but a robot created by scientists. Okay, so Doraemon is a program that runs continuously as a background process. Background, whenever a computer is run, inside the background what is running, a Doraemon process is running. Okay, and they are started, and when the system is bootstrapped, means turned on, and terminated when the system is shut down. Okay, when the system is shut down, the Doraemon is broken and thrown away. Okay, so the Doraemon characteristics. So the characteristics of Doraemons are Doraemon run in the background. Okay, so this is the system, and inside the system in the background what is running, Doraemon is running. Okay, they have the super user privilege. Okay, the Doraemons have super user privilege. Doraemons do not have controlling terminal. Okay, it do not have the controlling terminal, it runs in the background, and Doraemons are session and group leaders. Okay, Doraemon is what, a leader. Okay, so these are the four characteristics. It is fixed. Yeah, you cannot make changes to it. You have to by heart it as such. Okay, very important question. And next, the coding rules. Okay, so few coding rules are here. Let's go through it. Call the unmask to set the file mode creation mask to 0. Okay, so mask is set to 0 here. Okay, so the file mode creation mask is inherited. That could be set to deny certain permissions. Okay, and call the fork and have the parent exit. Okay, when a fork is called, at that time the parent exits and the child process remains. Okay, that is another coding rule. Third is call set id, set sid to create a new session. Okay, for setting the session id we'll be calling set id, set sid. Okay, and change the current working directory to root directory. Okay, to transfer from the a normal process to a Doraemon process, we'll be using the we have to change the current working directory to root directory. Okay, and unneeded file descriptors should be closed. Okay, some Doraemons open file their descriptors 012, and that any label any library routines that try to read from the standard input or write to the standard output or standard error will have no effect. Okay, so the descriptors present here, this will be having no effect to the processes run by Doraemon. Okay, so here is an example program, the program to transfer a normal process to a Doraemon process. Okay, so this is the example program. Here the header files are given to us, and here we'll be writing in int Doraemon initialize, and here we'll be writing PID. If PID is equal to we'll be running a for loop. If it is less than 0, return -1. It's not possible. Else if it is not equal to 0, then also return the parent exists, and the child will continue from here, setting the session ID. Okay, and the directory is changed and unmask is set as 0. All the rules, coding rules which we discussed, that are performed here. Okay, then only we'll be able to change the current process to a Doraemon process. Okay, and error logging is also present here. Okay, one problem a Doraemon has to handle is about error messages. It cannot simply write to the standard error. Okay, that will be stupidity. If an error comes writing to the screen, it should handle it. Okay, the Doraemon should be smart enough to handle the errors, not just writing to the screen. So this is a technique designed for handling the errors. Okay, so what it will do is it will run a windowing system. Okay, here the user process is there, logs are given here, and the UDP port is given here, and all the errors wherever it is come, it is getting logged into syslog. Okay, so this is the thing which is given for error logging, and three ways exist to generate log messages. Okay, first is kernel routines can call the log function. Second is most user processes or Doraemons call the syslog. Okay, Doraemons can call what? Syslog. Okay, and user process on this host or some other host is connected to this host by TCP/IP network. Okay, so normally the syslog Doraemon reads all the three forms of logs. Okay, it utilizes all the three forms of log messages. Okay, at different points of time. Okay, and this is the syntax for the given for the logs. Okay, open log, syslog, and close log, and set the log mask. Okay, moving on to the last super important question of this module. Explain the following functions. Okay, some functions are given, we have to explain this one. Okay, first is system, next is sleep, then is sig set jump and sig long jump, sig init, sig alarm, and kill. Okay, also we have another one which is the sig action. Okay, I have put it at the end, sig action also. So what is the system function is using C to execute a shell command from within a C program. It is a part of C standard library declared in stdlib.h. Okay, so system has a command here which will be run. Whatever the command we specify here, based on that it contains what is to be run, and that will be run here. Okay, so it returns 0, it performs no actions if nothing is there, and on success it returns the exit status. Okay, on failure it returns -1. Example is given here, status system echo hello world. This is the condition given to us. So if it is -1 means error is occurred, if it is not means it will execute successfully the following command. Okay, so hello world will be printed. Next is sleep function. Sleep means pause for some time. Sleep means pause for some time. Okay, so based on this function we'll be able to pause the program for few seconds. Okay, and this is the example given to us. Sleep 3 means sleep for 3 seconds. Next is sig set jump and sig long jump. Okay, set jump means where we are setting the program to jump. Long jump means performing that jump. Set means setting the jump, and jump means performing the jump. Okay, so sig set jump and sig long jump, this is the syntax for it. Okay, it is created to support signal mask processing. Why these two are created? It is used for supporting the signal mask processing. Okay, it is implementation independent if a process signal mask is saved and restored. Okay, only difference between these functions and set jump and long jump. See, set jump and long jump are also there. This is sig set jump and sig long jump. Here signals are involved. Okay, here signals are involved, so additional argument will be there. Okay, and a few more information is given here. How do we handle the APIs, and what does signal mask do, and different types of processing in the environments. Those things are given here, you can go through it. Okay, and the program is given here. There are some header files which are declared for the sig set jump and sig long jump. Here function call me is defined and long jump is called here, and env is specified here. So wherever the jump is set as env, from there the program will be starting. Okay, so you need not remember this as such it is. You just have to get a slight idea, okay, what all is being called. For example, here we have sig data empty set sig mask. Okay, and here we are declaring the data types like sig set and the variable name is sig mask. Here is the sig action and the action old action we are declaring here, and here we are doing action dot sa handler, action dot sa flags. Like these kind of things you have to write in a way that it does not look that it is a wrong program. Okay, so if you are able to write, hopefully you will be getting the marks as well. Okay, and moving on to the next one, we have sig init, sig int, and sig alarm. Sig int means signal interrupt. Okay, signal is that we are interrupting a signal. So sig int is a signal sent to a process to interrupt its normal operations. It is typically generated when Control C is pressed on the terminal. You have observed, right, in CMD, if you put if something is executing, if we type Control and C, the execution stops. Okay, whatever is executing, it will stop. Right. This we have seen in the lab programs. So this is a signal which you are passing to stop what is currently executing. Okay, for that sig int is used. So signal number is 2 here, and program is given here. The program is not important. You can just go through it for reference. In case you don't know about much about what to write in theory, you can write program similar to this one. Okay, next is signal alarm. Why is signal alarm used? It is a signal sent to a process when the timer set by alarm function expires. If an alarm function expires, signal alarm is sent to notify that it is to be replaced. Okay, and 14 is the number which is used, and the corresponding function of it is also given. You can go through it. Next is kill. Kill means what? Kill means finish a process, stop a process. Okay, so this is the syntax of kill. Here we have the parent ID and the signal number which we want. If parent ID is greater than 0, the signal is sent to the process whose parent ID is PID. If it is equal to 0, it's sent to all process. If it is less than 0, it's sent to all process whose group ID is equal. And if it is equal to 1, it means it will be sent to a system which has the sender's permission to send the signal. Okay, that was about the kill. Sig action. What does sig action do? It blocks the signal and catches, allowing a process to specify additional signals. It blocks the process. It blocks the signal, and it allows the process to specify additional signals to be blocked when the API is handling a signal. So it just acts as a blocking the signals. Okay, for that the sig action is used. This is the syntax of it, and here the data structure is given to us. Here we have the SA handler, and we have the mask and the flag. Okay, three things are there: handler, mask, and flag. Okay, so what it does basically here, it can be set to sig ign and sig dfl or a user defined signal handler function. It can be set to different types of functions. Okay, it's the sig action. So what do these different actions do? The SA mask will specify the additional signals. This one, okay, it will specify the additional signals. Like SA handler has this type of different handlers. Like that, SA mask will have different additional signals. Okay, and the flag will be having what flag is to be made true or false. Okay, and the previous signal handling method is signal number will be returned in via the old action. Okay, so this is the program which is related to sig action. This also you need not memorize. This is just for your information, and if they ask for this separate 10-mark question, in that case you need to write this one. Okay, just go through it. Here we have similar functions call me, and here we are declaring some variables, and we are calling some if conditions, and errors we are printing. Okay, and actions as a handler and flags we are setting. If you just memorize one of them, okay, by slight changes you can attempt all the programming type questions. Okay, so that's all for this video, and please do like and subscribe. It has been more videos like this, and don't miss any of these questions. These are very super important ones, and thank you so much for watching. I'll see you in the next one.